The logarithmic function ln of x is equal to 2 times inverse hyperbolic tangent of x minus 1 over x plus 1. We'll generate the data set of these functions from 0.1 to 1.9. And we generate also the Taylor series expansion. Begin with the logarithm, which is array formula ln of the x values from 0.1 to 1.9. And the inverse hyperbolic tangent, so is equal to array formula ATANH h of x minus 1 close parenthesis divided by the quantity x plus 1. And we multiply this by 2 times. Their values are exactly the same. Next, the Taylor series expansion, which is the summation of a times x minus 1 raised to the power n, where the value of n is from 1 to infinity. 20 is good enough. And the value of a is equal to array formula minus 1 raised to the power the quantity n plus 1 divided by n. Now we can generate the data set of the expansion. So array formula series sum. This is x minus 1. So x minus 1 raised to the power n, where n starts from 1, incremented by 1. And the coefficient will be this range. And we chart this. Insert chart. And we use column A as label. We use the scatter chart. We don't need the title. And show the trend line. Under series, show the trend line. The type, logarithmic. And the label, use the equation. For the legend, we can position at the left. So here's the trend line and a polynomial. Or the logarithmic function. So these values in blue has 0 plus 1 ln x. That's the logarithmic regression. For the values in red, 8.88 times 10 to the minus 17 plus 1 ln x. This is already 0, very close to 0. And our expansion, which is 6.83 times 10 to the minus 4, which is very small already, and plus 0.989. If we increase our values of n to a higher value, up to infinity, this value will be 0, and this value will be 1. So this completes the use of Taylor series expansion of series sum of logarithm and the use of inverse hyperbolic tangent.